not going to. Hello, Professor Devashish Sarkar. Am I audible, sir?
Yes, audible, audible. Am I audible properly?
Yes, sir.
Or
You're
volume
audible.
is volume is okay? Hope so. Volume is also okay.
Sir, Professor Sarkar,
Yes,
uh, you have been made co-host, okay?
yes,
So
okay,
that
okay.
presenting should be easy for you, okay?
Yeah,
The program will start from around 11 o'clock, okay?
okay, no issue. I'm available.
Hello, everybody. Good morning. Uh, I I am Professor Sandeep Sarkar of KCM. The FDP will start shortly at 11 o'clock. I hope everybody is audible. I hope everybody can hear me.
Yes.
Hello, good morning, everybody. I hope I am audible. I am Dr. Sandeep Sarkar, Assistant Professor of Greater Kolkata College of Engineering and Management. Today, Professor Devashish Sarkar, Associate Professor of Asansol Engineering College, will be giving an lecture in this FDP session. I am now presenting a brief intro about Professor Devashish Sarkar. Dr. Sarkar presently working as an associate professor and as well as HOD of Mechanical Engineering Department of Asansol Engineering College, West Bengal, India. He graduated in Mechanical Engineering from Jadavpur University, Kolkata in the year 1998. He completed his master's degree in mechanical engineering with production specialization from Jadavpur University, Kolkata in year 2000. He completed his doctoral degree in 2017. His interest lies in the field of high-speed machining, maintenance scheduling, and modeling, 3D printing, advanced manufacturing technology, and prediction of engineering systems, particular in railway systems. He has published more than 25 international and national journals and conference papers. He authored 3 books and 4 patents. He serves with various capacities that include principal in charge of Asansol Engineering College, as well as Asansol and chairman of Techno Commercial Institute, Asansol. He is fellow of Institution of Engineers, India, and chairman of IEI Asansol Load Center from 2023 to 2025. He is a live member of various professional societies like ISTE, AEI, ORSI, IA, PQR, ISHRA. Okay. Now, Dr. Sarkar, platform is yours. You can present and enlighten us. Okay.
Yes, good morning, everybody. Am I audible?
Sir, you are audible. You are audible.
Yeah. So, yes. Thank you, everybody. Thank you, Professor Sandeep. So, for being my nice introduction. Let me share my screen. My screen is visible. Anybody can?
Yes, sir. Your screen is
Yeah.
visible.
I'm keeping my video on. Initially, I am basically will expect some introduction. This I am very thankful for inviting me for this 1 week FDP on research methodology and effective teaching and learning organized by the Department of Basic Science and Humanities in association with R&D cell of Greater Kolkata College of Engineering and Management. The term research methodology and effective teaching learning itself a big area, particularly if you think about the research methodology. It has no boundary of its own. Because we know that the research, whatever we people are basically doing, or we have done exactly, every people having some different way of thinking, or own way of thinking, own way of logic, own way of innovation. invention. So we can say that this research is basically has no boundaries. And it is basically beyond our syllabus. So what as a researcher, as academicians, I am basically going to share some of my experiences, my own experiences, some experiences shared from my fellow friends, guide, and colleagues. Even I can say that something which is basically experience from my students also. And particularly, I will stick to this part of this research. The second part, which is basically teaching learning. So I'll not cover this. But still, when I am basically going to discuss something related to this one, that is also part of this effective teaching learning. And this teaching learning has basically is going or moving with a manifold, which we know that some methodologies, teaching effective teaching learning methods, we adopt, we know, we are using. I cannot say that all because I do not know what is basically going to happen in the next morning in terms of effective teaching learning. And this teaching learning has become a challenge to the people like we people, where we are basically thinking about not only the teaching, because our teaching, particularly in a uh, professional course college, like we people, engineering colleges, so they are not coming with the objective of getting marks, getting knowledge. They are also having another objective of getting a placement, or we can say that job, or maybe some people are also uh, interested in maybe for higher studies, research, all this. So in that particular case, the effective teaching learning is very important, and particularly when we are in a phase of, we can say that outcome-based teaching learning, where we are thinking about the what will be the outcome of this classroom teaching, or we can say the teaching learning. We are talking about that initially when we people like where we are having an age of 50. When we are in the school, we are thinking about the classroom teaching only, not teaching learning. Now we had a series came the teaching learning. Presently, we are talking about the outcome based. At the same time, as per NEP, uh, new academic education process, new education processes, we can think about that. It is basically going to promote towards that people can leave any time the course they can join in future after doing some job. So that will be it will be another challenging phase in effective teaching learning process. So we have to be always in a mind that what is basically the learners is looking for. And we have to minimize our objective to the objective of students of there. And if we can minimize the gap between these two, then we can say that that will be the effective teaching learning. Otherwise, that will not be effective teaching learning methods. Though, I have not very much the knowledge about this because I can say that this is effective teaching learning, but to some extent, we are doing in the accreditation from our department, from the College of Social Engineering College. So we have some idea how to make it effective. I can share some of that, but particularly it's a research methodology. Particularly, I am basically from mechanical engineering. So myself, Dr. Devashish Sarkar, as a professor and head of the Department of Mechanical Engineering, Department of Social Engineering College already. Professor Sandeep Sarkar has mentioned that I am particularly related to that, the maintenance modeling, manufacturing areas, and system design. So in this particular case, research, many people are basically having the different direction of work. Some people basically maybe doing some work of simulation. Some people are doing some work of absolutely innovation type of work. And some people are also doing something like me. Data collection is very important because for my research, so basically data collection was very important. So data is basically whatever you know that, and the students, the present education system, present uh, professional education system, particularly where a large number of people are basically moving towards that digitization. In other way, if you can say that crude way, most of the students are basically looking for that. They want to go for the computer science. But what computer science is basically doing in the research? So one part is basically what I'm talking about, that they are basically doing data acquisition, data storage, data analysis. And but next part is that whatever we do basically, because we are not from computer science, like a mechanical, civil, electrical, we are term or on up to one particular domain. We are basically interested to do some experimental part of this. So for experimental part of this one, basically whatever we are doing, we are basically collecting data. We are generating some data. Basically. Same thing, computer science is also doing in different form, because everything is basically now we are defining everything in terms of data. So for this one, my topic has been selected as data collection and analysis of variance. So where I will basically talk about that, how we can calculate the variance of this data set and what is the effect of this variance of this. And this particularly, I can say that this particular FDP, as we know that we can do it that two way. One is that particularly the research is basically for faculty, those who are doing research. And another part is this one, that as a teacher, our another objective is to encourage our students to do some research. To research in other way, we can say that we need to motivate our students for publications for their final year project, particularly. Maybe that final year, some department they are basically starting from that third year also. Third year also. So for this, we can say that yes, we can say that this research is basically for students. So if we can motivate the students to do something, so include some mathematics, some software in their project part. So then we can say that our teaching will be effective, teaching or learning. So keeping in this mind, I have done this. My topic is basically data collection and analysis of variance, and it's practically I'll show you that two calculations. And so that you can motivate your students to calculate towards that analysis of values. So when we are talking about the data collection, basically data, whatever we are collecting exactly, which is basically experimental part of this. We are basically measuring something. So yes, I can say that measurement. When we are basically going to the something data, basically doing something measuring, we are basically quantifying something. Or this measurement is nothing but the assignment of numbers to a particular object. If I can say that, whatever I am having, say, I can say that, yes, I have uh, simply I can say that, yes, this is my a particular, uh, say, length of something object, of circular object. So what is basically, I am basically talking about that. What is the measurement? Measurement is, we can say the length of this one, or I can say that the diameter of this one is basically my measurement. And I can say that this I am assigning the number against the length of this one. And it is nothing but the foundation of scientific investigation. If I can say that some organization is basically producing some rod, say maybe pipe. So whatever basically, or we are investigating that is the length every time it is producing is of same length. Is that what is basically producing of same diameter? If not, what is the problem behind this? If I talk about that this problem behind this, then obviously we can say that there is a part of that uh, statistical quality control. So we are basically taking the data, we are measuring, and we're trying to find a finding on that. I'm getting the proper dimension, proper variance. So we can say that if we can measure, anything will get measured. And if the measured is basically within my limit, then I can say it is control. So here you can say that the two terms will be arise. One is basically limit and variation. Limit and variation. So I can say that my objective is to get the diameter of this one is basically 30 millimeters. And if I am basically producing this one, I can say that this will not be always 30 millimeter. It may be 29.99. It may also vary from 30.01, just like this. Or it may be sometime, suddenly you can say that it may be 30.05. Or it may be the lowest side, 29.90. So I am basically talking about that variation is basically 29.90 to 30.05. System is giving this. So this is basically we can say variation. But when I'm talking about the limit, is basically allowable variation. Limit is basically allowable. I am basically allowing allowable variation. That means I'm talking about that. Yes, my production line is giving me variation, some variation due to some uh, variation of the material, variation of the temperature, variation of the machine itself, variation of the worker scale. So there are many parameters are there. But I am talking about the no. My 29.9 is not my allowable. My allowable basically, it is basically 30.00 plus minus 0.01. 0.01. That is, I can talking about that. It is basically varying between 29.99 to 30.01. This is my limit. It is allowable. If it is allowable, my the product is basically okay, acceptable. But beyond this is not acceptable. So then it is basically I'm talking about my measurement, the system having a variation due to the system variation, due to the system error, due to that system some deviation, we can get it. We are measuring this one. And I am keeping about that. I am basically giving allowing some variation because I cannot say every time that my objective is to get 30.00, but no system is basically 100% perfect. Can give you always 30.00. There will be some variation. And out of this some variation, it is basically maybe within level, maybe out of this level. So it is basically one thing I'm talking about that because my objective was basically to take data. I am basically interested about data because maybe many faculties, many members are present here is basically doing some experiment every day. Every day, no, we are basically engineer equivalent, basically doing experiment, lab-based one. Whatever we are doing, we are basically generating data, experimental data. Now, some data, raw data, we are collecting. Uh, can you say that this data is basically effective and efficient? This term, effective and efficient, which will basically effective means I can say that yes, what I wanted to get it, and my objective was to get this data from where we can just finally can infer, conclude something. So then I can say that yes, this is the data is basically effective for my analysis. And finally, which will give me that conclusion. So then it will be basically efficient. So I can say that yes, I am basically collecting data, raw data, that may be something variation. And this variation, I can find out that if I can measure it, I can find out what is the variation. So I'm talking about that is basically is a measurement, assign number through my scientific investigation with some instruments, systems, machines, and finally I'm trying to find out it is controlled or not. So if I think about that, it can measured in the different scale, maybe nominal scale. If it is basically it is really a scale, it is not really a scale because it does not scale object along any dimensions. It's similarly level. That is basically I can say that nominal scale is basically a gender, which may be male or female. Basically, it may be color, red, yellow, blue, green, black. We are basically measuring this. But still, you are basically those who are doing research, you know that. This also we can find out this is just like a color in computer. We can find that 256 colors. So it is basically some fuzzifications is also there in this scale. We are basically really we are doing on this. It may be measurement can be in the ordinal scale, which is basically numbers are used to place object in order. That means it is basically we can say that in rank order system. But there is the information regarding the difference between two intervals. So I can say that I'm basically putting is the over average, above average, good, excellent, whatever we are doing. Sometimes we are grading. How do you feel today? It is very happy, unhappy, okay, happy, uh, uh, that very happy. So very unhappy to very happy and having basically putting in order. So this also what we can do in this particular case, ordinal scale for research, what we can do in this particular order scale. We can also do a research related to the something like I can say that some of you may have idea about that MCDM, multi-criteria decision making. So there we are basically interested about that order, rank order system. We have some calculation, just like we can say that some people are basically with AHP, analytical hierarchy process. Some people are basically working with the Topsys, Electra. Say from some people are basically hybrid in basically Apache, Apache, ASP. So there basically people are doing ASP Topsys people are doing. So you can do this that order basically you can make the order using some multi-criteria decision making MCDM method. People are also doing this. So then we are can measure in terms of the interval scale. Interval scale just cannot be the equal interval between objects, which represents equal differences. The interval differences are meaningful. Meaningful. There is no true zero. We cannot define the relay ratio. So, for example, we can say that in Fahrenheit, I can say that this plane two differences 20 to 30 degree. That is basically interval of 20 to 30. It is 10 degree. Here 70 to 80 also 10 degree. But we cannot say that this difference is 60 degree. That is, we cannot say that 60 degrees twice out of 30 degree. That is, there is no zero, true zero in an arbitrary zero scale. Then we can say that is the ratio. Here is the true 0 point ratio. I think so, which is also notable. We can say that is in a time we can say the 40 seconds is twice as long as 20 seconds. I can represent, I can measure it, the ratio stuff. So the measurement is basically like I told you that if it basically for any system process, the measurement is very important. When we can say that process is under control, process is beyond control, and how we can keep that process within this our limit, and we can do this. And where we are talking about the data, etc., we are basically doing some data we are collecting. Whatever we are talking about that, these data are basically to us for a researchers, for a engineering practitioners. And these are basically the variables we are basically measuring. We are trying to find the system with this variation of this. So this is basically a variable in the characteristics, number or quantity that can be measured and counted. A variable called a variable because the value may vary between data units in a population and may change in value over a particular time. So this is basically, we can say that whatever variable we are talking about that is X, business, income, and expenses. That is, we can say that capital expenditure, class grades, eye color, vehicle types, example of different variables. We are basically working with this one. Same way we can think about that for this particular case, that what is the effect of this the result, maybe that result, and we can think about the result scale, we can say that about the aptitude test result, how it is basically giving the efficient students which are basically getting the job for people. So result is only the theoretical part, whatever we are syllabus they are covering, their result is the ultimately giving the job or some others is giving the job. That also we can do this. That is basically we are basically trying to get it. So if it is categorized these variables, numerical variables, categorical variables, continuous variable, discrete variable, numeric, or it can be categorical in ordinal and nominal. So we have already discussed something. So I can say that this basically numerical variables is basically values that describe a measurable quantity as a number, such as how many and how much. Other words, numeric variables are quantitative variables. And numeric variables are classified as continuous variables and discrete variables. So categorical variables have values that describe a quality or characteristic of data, such as what type or which category. Categorical fall into the mutually exclusive and collectively exhaustive definition. They are qualitative variables and represented by non-numeric values. Categorical variables are classified as ordinal variables and nominal variables. But is so that you know that from my personal experience, I can talk about that. Sometimes whatever we are talking about this qualitative variables, and that also no, we are in present research stage, we are also trying to quantify this. If we can quantify this, we exactly can calculate, we can make a logic. Though without this quantity, we also can logic, we can put a logic. But here it will be more easier to calculate, to set the logic. And I can say that when we are basically doing some railway system, we are also doing some analysis. We did some analysis on human reliability and the uh, train delay, system delay. So human reliability and system delay. We did some calculation, and we found that that also published in some journal. See, you are getting that. People are basically also thinking in this fashion right now. We are doing so that there is basically fuzzy quantification is also helping a lot in this. I think so that if you are someone is interested, you can personally you can contact, we can discuss so that we can move ahead with this kind of activities. So people are doing in today's. So though most engineering people are basically interested about the directly quantification and experimental part of this. So however we can say that these are basically data collection. So we can say that it is basically a part of the statistics branch of mathematics that deals with the collection, analysis, and interpretation of data. And data can be defined as a proof of information that represents the quantity, quality, activity of this. And data collection methods, we can say that census data collection, where we are talking about the all data collection, sample data collection, we are basically taking part of data, experimental data collection, where we are basically doing experiment and getting this observational data collection, where we are basically observing some movement, something, where we are basically observing some system and we are collecting the data. So basically, normally the engineering people are doing. But if you think about this sample data collection, it is basically having a large statistical significance. And we can think about that acceptance sampling. We can think about that process capability analysis for this different experimental data collections. We can think about this. So this sample data collection having a, I mean that we are having a large significance in our statistical analysis, because some cases now we cannot do the measurement particularly for all cases, particularly where the measurement is basically destructive. Sometimes the measurement of or inspection of 100% is basically time consuming. Large, it takes a larger time, large time. So there is basically sample data collection, where we can say the acceptance sampling is very, very important. Say sometimes we can say that if we say that sometimes in pay days, though, if we go to the shopping mall, every shop we are getting that the discount, the 50% discount. When if we could find that no discount is given, normally many people try to avoid it. No, I'm not giving any discount. Why I'll go there? That is basically cost is huge cost. So that is basically one part. But earlier, we were basically thinking about that this discount was basically other we can say that the consignment acceptance failure. Acceptance failure. Sometimes I used to say that say you're purchasing some sweet for your guests. So how you can ensure that the sweets are good? Sweets are good. So there are basically some acceptance sampling is there. So what we used to do that we used to take one or two. We used to do the taste, the sweet, and if we find that sweet is good, we can say that the whole lot is good. If we find that the sweet is whatever we tasted is basically bad, we can say that whole lot is bad. But obviously beyond this, there is some situation where what I tasted exactly that was bad, all rest was good. In other hand, I can it may be also that what I tasted that was good, but rest of the whole lot was bad. So there is some chance of happening of this situation where the part what I tasted was bad, but rest was good, or what I tasted was bad and rest was good. So same thing. One was good, rest was bad. One was bad, rest was good. So that is basically what happens. So for that one, there are some statistical calculation, statistical acceptance sampling, and process double analysis. That one from where we can do this. And I have gone through some statisticians the session, but they're talking about that they're taking that opinion poll from the American election. They're taking the opinion poll of 100 people, and they're basically finally inferring or concluding that who will win that American presidential election. And they're basically nothing but is basically that acceptance sampling and calculation. So where we are basically collecting data, we should be very careful about this. Very, very, very careful about this. So there will be some, obviously there are some variation, deviation, the way you are collecting that is also very important. So even if I can talk about that, I am talking about that field, the engineering perspective. But if I can think about that, this data collection, it may be the whatever the way we are basically, it may be the primary data collection or it may be the secondary data collection. So primary data may be collected through observation, interviews, questionnaire, and we have a scheduling of this one for collection. But if it's secondary, it may be data gathered and recorded by someone else. It involves less cost, time, and effort. Secondary data is data that is being basically used, usually in a different context. So for example, data from book, magazine, newspaper can be collected from the internal external resources. Now, from my personal experience, I'm talking about that. I basically did my PhD on railway maintenance system, where my objective was to basically develop a system where something is basically some model where we can make some maintenance scheduling, where the existing thumb rule system can be more scientifically, more mathematically, so that delay can be minimized, or the maintenance time can be reduced. So for that, I basically collected the maintenance data more than 5 years from some section, specific section of Indian data. Now, what are we talking about the primary data and secondary data? Basically, in this particular context, I can say that I basically collected this data from some written documents for some maintenance activity that was kept in the ledger. And finally, or what I found, this data, I can say that the person who observed, who recorded, that is basically, I can say that is basically primary data. But when I was using the for my analysis, I can say that was basically I was secondary data. But when I basically observed and going to analysis of this, to record of this, and I found that there are something basically many manipulations in there that is not recorded properly, not recorded with the real time. Yes, so this is basically is a big problem system. So there are every system just like having some advantage, disadvantage. Here also we have some advantage, disadvantage. So we should be very careful about this. And with this, after that, after collection of this data of 5 years, then what I did exactly, I started basically the discussion with the maintenance profile, which I took a long time. Until long time. I was for several days in that area, particularly. I can talk to you about that Satragasi area. Or I was basically many days for long days. I was basically accompanied with the maintenance people, those who are maintaining the system, and I was basically trying to find out what time basically they are taking, what say such kind of same thing, whatever I have found recorded from that ledger, I tried to correlate that what is the very normal time and what they're writing right at this moment, and how they're writing, why they are writing, so that we can at least predict something, what may be the variation when they record it. I know, I know that sometimes maybe that some people are recording exactly. Some people are not recording exactly. They are manipulating. But obviously, there is something I have to accept, adopt, that some reduction of time, some addition of maintenance time, some addition of activities, so that we can say that, yes, from this secondary data, I am basically making the data effective, which finally will help me to prepare my maintenance. So I'm telling you that this is basically the real hurdles. Hurdles you may face when we are basically collecting data. We are working with the large data. No, simply I can say that when we are basically such time of that, where every day we are basically maybe that we are putting our fingerprint biometrics that as our attendance. So some people are basically they're storing this data somewhere. It is basically stored, and someone is extracting from this data. So maybe that by some mistake, by some operation, by some clicking on my say maybe the keyboard on my laptop or computer, maybe that there is some variation, intentionally or unintentionally, has been taken place on the record of the attendance of that particular organization. So who will ensure that this data is exactly correct, maybe intentionally or unintentionally? So there may be some variation. So that is basically the difference in the primary data and secondary data, whatever we are basically working for research purpose. So we should be very careful about all these systems. So this data analysis, obviously, when I'm talking about that data analysis and data representation on this. So one is basically I'm talking about data collection. When you are basically collecting this data, after that we are basically trying to effectively arrange this one, analysis this one, and exactly we are finally representing. So when I basically as a researcher, My analysis conclusion, my representation on the paper basically will give you the your outcome simply. So where we are basically using acceptance sampling, whatever I have told you, slightly part of this. Then obviously we are having this hypothesis testing, and this hypothesis is nothing but basically we can say that it is basically our claim. I am basically considering this one. If I think about that, yes, the say mu1 of a set of data and mu2 set of data is basically the same. I'm talking about the mu1 is equal to mu2, and it is basically null hypothesis. If it is basically not, so there will be some alternative hypothesis. So we can say that this is basically hypothesis testing our claim uh, or say maybe that uh, my assumption, and obviously for this particular case when you are talking about that assumptions, if you go for that, they say maybe that I can say that it may be that our true and false in terms of the my assumption and claim. So if I can say that basically true and false, then if you're having also a true and false, so we can say that if all this, if it is a true, and it may be that uh, uh, true false, or it may be that we can say that false true, and it is basically all false. So these two basically to this coordinate false, what basically we assumed true and it is basically exactly true. It is basically we assumed fault and is exactly false. This is basically S2 is basically correct. But where in these two areas, I can say that when I am basically talking about that, my assumption was false, but it is basically was true. And here my assumption was true, but actually it was basically false. So I can say that it is basically type on error, and we can say that it is basically type 2 error, and we can say that type on error and type 2 error. Then we can say that there will be a power of the indices. So then obviously this hypothesis testing, we have to be very careful about this one. And from here, we also can find out the minimization of this time of type 1 error, type 2 error. And obviously, there will be some analysis part in there. In case of that representation of data representation, there are 7 quality tools: Pareto chart, scatter diagram, so such diagrams that we can represents. And here we can say that present day what people are talking about that the machine learning. So this statistical people are basically doing for a long back. They're basically doing prediction with this quality control tools where they're basically doing. And not only that, we're talking about that forecasting is basically mathematics, where basically the statisticians are basically doing for a long back. And now what basically with the advancement of the computer technology, the calculation, whatever is becoming easier. We can do the program, we can write the program, we can do this calculation. It's simply, I can say that 3x3 matrix inversion is, I can do it, we can do it, all we can do it by your own hand, pen and paper calculation. If we go for the 4x4 matrix inversion, I mean, inverse of this one, it's basically tougher. It will time consuming. But if I say a 6x6 matrix, but manually, it's really difficult. But computer has done all this. So now the same way, forecasting. So if I can say that when I am basically did my time series analysis of this maintenance, I use this MATLAB Ariba model. So I can know that this basically we sometimes we do basically manual calculation. But now people can do it very easily. So in the research, no, you have to be very careful about all these materials case for these cases so that now you can do it very easily. You can do it very, but the logic should be very clear to you. The same thing, whatever I'm talking about that, what is basically type 1 error, type 2 error. So we can do it. Now here in this particular my discussion, I will basically will enter this my variation. But here is basically coming from this basically type 2 error, type 1 error. But here what we can do in this, when we are basically doing the analysis, we have to find out how data was collected, what may be that error. Can I minimize this error? How we can do this? If we can do this, then I can say that my analysis was effective and efficient. So now I'll basically enter into this one. It's basically that analysis of variance. So this analysis of variance, the name itself says that variance. There is some variation. As I told you earlier that I cannot say that my objective was to get the measurement is 30.00. No, cannot get. But there is some variation. Some variations. So these variations in different cases, the different people, maybe the mechanical production is being only, some other also doing the different. The nature of data is different. Maybe I told you that the categorical data, ordinal data, nominal data, all this basically we are having. So with this, but this analysis of variance is basically the itself the variance. I'm basically analyzing this one. And finally, we are basically going to for some. So analysis of variance was developed by R.A. Fisher, a British statistician, and basically experimental design and inferences. So I'm talking about that experimental design or something, Taguchi design of experiments is also very important in this. The people, those who are working with the data observational or I think experimental data. Yes, so Fraser developed in 1922 this method analyze the difference between multiple sample means multiple sample means. So I can talking about that. Say 6 months back when we are basically working with the experimental analysis. Particularly, I can say that I was basically working with the machining, mechanical, those who are mechanical, to them is very clear. We are basically doing a high-speed machining of super alloy, nickel-based alloys. So it is basically challenging with a very hard nickel-based alloys, which are basically used for say shipping applications like that, where large amount of machining, I mean material removal is required. Large amount of material removal is required, where we cannot do something like very, I can say that advanced manufacturing processes. The advances of this particular manufacturing will be particularly where I can use computer programming for this one. But ultimately, the challenge is basically large amount of material removal is required. A large amount of material removal is required. How I can do? I can do this at high speed or high rate of removal. But high rate of removal is basically gives, rather we can say that the more, I mean, say tool wear and tear textbook. So it is basically there is another option or another solution is that where I can do that high speed, low removal, but at a high speed. So ultimately it will basically compensate with this. But it is found that at a high speed, again, the temperature is basically very high. Very. So we can say that there are some uh, challenges were there, and we did with some setup. Now, when I'm basically going to discuss with some people of ISI Kolkata, he from the data, he told that I do not know what is called you're talking about machining. I know statistics, but first let me know, let me ensure that whatever you are getting the variation, whatever you are getting the data, is there any effect of the system uh, variation? So if you're talking about that, then he told that, have you done the same experiment twice or thrice? And have you checked that with the same experimental condition, that whatever value you are getting, all these three are becoming same? Or what is the variation of this? That means, if I can say that, he told that if I am having, say maybe that three level of, say, I think so, those people, those who are basically mechanical people, you can say that speed, you can say that feed, and you can say that depth of cut. If you are basically having, you are basically taking these values of, I can say that you are taking all these are basically, you can say that he told that yes, you are basically doing, say maybe that at three level, high, medium, low, high, medium, low, high, medium, low. So normally when we are doing experiment, what we used to do that, say maybe that these three are basically the input variable. What normally we used to do that, we are taking high, then mid high, high and high is the first say set. Then whatever doing, keeping this high and high is constant, then whatever then we are going to this one. So that is the first one, second one, then we are basically going to this one. Now, what is basically happening now? Whatever depth of cut, we are basically changing high to medium to low. Then what will be second one, what will happen? Third is the third. Fourth, what we will do? We are keeping this high. Then we are going to medium. Then once again going to this one, and this. So he is asking that, why are you doing like this? Because if you are basically only changing this, there may be some hysteresis error will be there in the system. And you maybe that knowingly or unknowingly it is right. Are you doing some random experiment of this one? Because whatever you are doing, because if you say that there will be 3 to 3, so there is basically 3 to 3 to 3, that will be basically 27 experiments are there. Or you are doing HL, then HML. No, you do not do this. You do that. You randomly you take it that maybe that your onset will be first experiment will be HML. It may be that third will maybe that LMH. Maybe like this. That is randomly you are basically changing. You are changing this one. So this will be for better. Instead of otherwise, you have to do this. You have to do this. That take this HHH three times. You see what is the variation. If the variation is within the limit, then you can say that yes, the system has the effect of this. System has the effect of this. So that is basically is very important. So even we are when we are basically talking about that failure, we are talking about that some cause is basically assignable cause, some cause is chance cause. Just like this, you know that if I am basically mechanical engineer and someone is basically computer engineer, so if I am giving to do the program by virtue, because I know I have a very limited knowledge about the computer science, I definitely will do the mistake when I do the programming. But can I tell you that all computer science people will always write the program correct? But the chance of failure is. So it is basically inherent. If I am basically not from computer science, I have an inherent deficiency. That's writing a good program. Writing a good program. So we should be very careful about this. So on the basis of this, there's some inherent system is basically have problem of doing this work right, or there is a chance because he is having a computer science paper, he is very frequent of we can say that writing program, but he may do the mistake, but mistake will be nominal. Mistake will be nominal. So that is basically inherent and chance process we are in. So here also we may get this. So when we are basically doing this analysis with the data, we should be very careful about this. So what is analysis of variance? Is we can basically analysis of variance is basically analysis of tool used in statistics. Splits the aggregate variability and found inside data set the two parts. This is basically systematic factor or random factors. Systematic factors have a statistical influence on the given data set, but random factor do not have. And tell the analyst if there are any statistical difference between the means of three or more independent groups. So if I can talk about it, though I basically will not go for that hardcore mathematics and this, I will try to show is what is the steps we are basically used to do. But now we can using some, we can say that Minitab like software, we can easily do the calculation where the large numbers of factors are there. But you see that my objective will be to show a small calculation by simply manual by hand, so that you can understand and you can finally encourage your students to do the some calculation, to input these calculations in your project, final year project, so that that can be published. So I think it's better. My objective is this. So these are the basically assumptions. Experimental errors of data are normally distributed. Equal variance between the treatments, independent of the sample, that is, sample is randomly selected and they're independent. So ANOVA techniques are basically two types of ANOVA, basically one-way ANOVA and two-way ANOVA. And it is basically nothing but the extension of the t-test. So in t-test, basically, if I do that, t-test used for two independent samples. So if we also can go for this, but further we have to do this more number of tests. So why it may happen that the type of error, increase of type or chance of decrease of type of error increase. That's why we will basically do this, the ANOVA test. So I here steps of this ANOVA. So first is that we will basically assume that this mean variance is basically equal, is basically null hypothesis. And alternate hypothesis, they are not equal. Then what we will do, we will calculate the mean of each sample and run the average, and we will do this. The step 3 is the calculate the difference between the mean of various samples and grand average. Square this differences at obtain the total, which is we have to find out for each sample. Calculate the sum of square between. Here is basically whatever we have to do. We are basically calculate this between and within. Between and within. So we have to between the samples. Then we have to basically within the samples. And we have to square these differences and obtain the total of these. And calculate the sum of the square within the sample, SSW. And we will put in this format. So we are basically source of variation, sum of the square, degree of freedom mean square. I'll just basically it will be clear to you. But for this particular case, whatever we are doing, we are basically considering that 5% level of significance, or that is in the other way, we can say that 95% of confidence level. We are basically giving that variation. We are basically considering that within 5% of variation, basically we can consider maximum at a 0.05. So here basically I can say that there will be the example very small. Here is basically I'm talking about that production of crop on the variety of seed, basically, whatever I'm talking about that for, say that here basically A, B, C are three types of seeds we are basically using, and we are getting basically there are some the production crops in terms of say maybe the tons, okay, and we are basically trying to find out that what is the effect of the seed of say maybe wheat, maybe something rice. What is the effect of this different kind of seeds? So what this one we are basically doing. They are basically on kind of thing basically. On way is basically on parameter, on factor is basically there. Okay. If it is basically more than one, so maybe that I also will show you another one. The seed and the plot or land, soil condition. I can say the soil condition effect of that. So we are basically we will do this. So now we are basically I'll show this calculation. So I told you that these are basically I can say that difference. This one. So this table is here. So these are basically production with seed A, B, and C. So now here the same thing. Whatever I have kept is basically A, B, C. I'm basically so what I'm trying to design basically. Sure that better. Yes, so I have kept the same table is at the this top corner of this one. So whatever same thing whatever I told you that we are basically having a the a test at 5% significance or 95% confidence level. So we are basically I told you that we have to find out our assumption. We are basically talking about that we are basically this is one sample set, second sample set, and third sample set. I am talking about that sigma 1 square is equal to sigma 2 square is equal to sigma 3 square. It is basically my null hypothesis is 0. We basically talk about that. If we're having a alternative hypothesis, will be H1 will be nothing but is equal to my assumption is sigma 1 square is not equal to sigma 2 square is not equal to sigma 3 square. Now here basically whatever we will do, now we are basically do our calculation. So the first we have first tested is this one. I have assumed this one. I am going to this one. So what is the if we go to the previous page for basically now we have the calculation of mean of each sample. That is whatever I am basically doing for this one, whatever we are having, x1 bar, which will be nothing but sum of all this column wise. This basically 5, 6, 8, 1, 5 is nothing but equal to 0 5 plus 6 is 11 plus this 8 plus 1 9 11 plus 9 is 20 plus 5. So it is basically x bar will be 25 by total number of sample is equal to 5. So this will be 5. So that will be nothing but equal to 5. X1 will be my 5 x1 bar. Same thing from sample 2, or we can say that A, for this is basically for A. If you say from B, that will be x2 bar, that will be sum of all this 5 plus 3 plus 2, 8, 10, and this is basically nothing but 20 by 5, which is nothing but equal to 4. And then what will be here will be for C, there will be x3 bar, which will be nothing but 10 plus 13 plus 7 plus 13 plus 17. It is nothing but is equal to 20. And here is 13 plus 7 is 20. Here is basically 30. So 20 plus 50 plus 10 equal to 60 by 5 is nothing but is equal to 12. And now there will be grand average will be 5 plus 4 plus 12 by 3. We can set that x double bar, which you can find out that 21 by 3 which is nothing but is equal to 7. This is our grand average of this. We have got it. Now, the calculation of the sum of square of the between the sample, sum of the square of the between the sample, whatever we have to do. We can do it this here. So we can say that for A, I'm writing here A. So beyond this, I'll do this. So those who are having a pen and paper, we think they can do that. That will basically, for these 5 samples, what we have to do here. Here for this one actually SSB. So here by my calculation of SSB is sum of square between the samples. So B stands for between the samples. So here is basically our grant is 7, and here we have got this grant is 7, and we have got this one S, and we have got this one. So here will be nothing but equal to 5 minus 7 is whole square, and that will be for this is basically between these samples. We are basically taking for the same. So this will be 5 minus 7 whole square. In this way, it will be basically all this. So that will be, this is nothing but 2 and basically 4, and it's a 4. So the 5 times of this one, the total will be basically 20. Same thing for B. This will be nothing but is equal to, here grant is 7, but here it is basically 4. So this will be 4 minus 7 of whole square of 4 times. So this will be nothing but equal to 3. So 9. So 9 of 4 5 times is equal to 45 is grant of this one if I go for this one. And same thing for C, that will be my grant is 7, but here is basically X. C bar is equal to 12. So 12 minus 7 is whole square is equal to 5. I mean 25. And 25 by sum of this will be nothing but equal to 5 tenths of 125. 125. So this is here. Sum of the squares, or how do we have to do this? SSB, I'm going to the next page, so it will be basically whatever that's SSB, which whatever we have got in the previous, we have got it basically 20 plus 45 plus 125. So this will be 20 plus 45 plus 125. So we are basically getting these values to 190. Okay. Then we have to do whatever we have to do. We have to do SS W with it. Whatever do this for A, whatever do this, basically for this, whatever do we have to do it. For each one, we have to do this. With that, whatever we have got it. Average was 5, we got it 4, and we got it 12. What we will do for each and every, what we will do? 5 minus 5 whole square, and with this one, then this will be next one is 6. So the 6 minus 5 whole square, then 8 minus 5 whole square, 1 minus 5 whole square, 5 minus 5 whole square. And we'll do this. That will be nothing but equal to, this will be basically 0, this will be equal to 1, 5 and 3 is equal to 9, or minus 5 will be equal to 16, and this will be 0, then this is nothing but equal to 25 plus 1 equal to 26. We have got the 26. For B, and the same way, how do we get it? It was basically a 4, and with respect to each between, within this, it is basically, we are basically taking about that 4 minus 3 whole square, 5 minus 3 whole square, then it is basically 2 minus 3 whole square. So this is nothing but equal to 1, this is nothing but equal to 4, it is nothing but equal to 1. 4 minus 2 minus, I have taken this wrong. I have taken this wrong. It is basically 3 minus 4. This is basically uh, 5 minus 4. This will be 4 minus 2 minus 4. So this is 4. So that will be 5 minus 4. This will basically 1. This will be 1 and this will be 4. And then it will be exactly 10 minus 4 whole square. Then it will be 0 minus 4 whole square. That is equal to 36. And this is nothing but is equal to 4 is basically 16. And here my 12, sum will be 6, 12, 16 plus 2, 18, 1 and 58. Yes, 58. So this will be nothing but is equal to, that is, I can say that here you are writing basically xi minus x1 bar whole square. Same thing, it will be xi minus x2 bar whole square, and c there will be nothing but equal to xi minus x3 bar whole square, and we are basically making it 10 minus 12 whole square, 13 minus 12 whole square, 7 minus 12 whole square, 13 minus 12 whole square, and 17 minus 12 whole square, and it is becoming 4, 1. It is basically 5, right? 25, 1, 17 minus 12, 5 is equal to 25. So this is 25, 25, 50, 55, and 156. So there will be basically 56. And sum of square within will be equal to 26 plus 58 plus 56 is nothing but equal to 140. Then whatever we are basically doing, we are basically preparing our this table. So what is the table? The sum of square between this, whatever we have got it. If you go to this one, anything? Am I audible to you? Hello? Hello? Anyone, please? Yes. Am I audible? I think so. Anyone, please? From the shortcut, sir?
Yes, you are audible, sir. You are audible.
Okay, I think so that suddenly this screen is stopped. Okay. Now, whatever basically I'm talking about, that it is basically the sum of square between basically whatever we got it. We got it basically. This is basically here on 40. You see this basically on 40, and where we have got it. So this is basically once again we got it earlier is basically this on 25 plus 45 this one. Whatever I have shown it here on 90 and on 40. Okay. That we are basically putting in this table. So here is basically I can say that this is basically on 90. Here is basically within the sample is basically on 40. And the total is basically I can say that 330. Whatever we are basically doing here, the degrees of freedom, now we are basically degrees of freedom. How many are basically here? There are 3 samples are there. So this is basically what C minus 1 is nothing but equal to 3 minus 1 will be equal to 2. Here there are 5, 7 total number of, rather we can say that 15 samples are there. So number of samples n is equal to 15 minus c is equal to 3. So there will be nothing but equal to 15 minus 3 is equal to 12. Okay. So here the total will be nothing but is equal to this, we can say that n minus 1, or we can say that this is basically c minus 1 n minus c. So this is basically, if we can say that n minus c plus c minus 1, which will nothing but equal to n minus 1, will be nothing but equal to 15 minus 1 is equal to 14. So with this, whatever we have to find out that this is basically mean squares, mean of this one. So what is this one? This is basically 190 divided by 2 will be this one, mean of this one. So that will be, it will be basically 95. And here this will be 140 divided by 12. That will be nothing but equal to 11.67. 11.67. And this F will be the ratio between this. It is basically SSP and basically SSW. Ratio of this mean square of this one and this one, where which is basically larger. This is basically, we can say that it is positive squared, so it is basically larger to smaller. So this F value will be 95 divided by 11.67, which will be nothing but is equal to, value will be is equal to 8.14. And this F value also we can find out, calculate, we can find out this from our table, F distribution table. With this S distribution table, we can say that this is basically will depend on this numerator and denominator, the degrees of freedom. So this is basically numerator. Here degrees of freedom of DOF, the degrees of freedom of numerator by denominator and denominator. So this is basically nothing but 2 by 12, because you have got a 2 here, you have got a 12 here. With respect to the 2 by 12, we can go to this table. So here you are getting that here F distribution table. So it is basically that degrees of freedom of denominator and F degrees of freedom of numerators value. So our numerator are basically 2 and denominator is 12. So numerator is basically 2 and denominators corresponding, this is 12. So we can take it, this is basically 3.89 is our value. So the F tabulated value we can find out in this, from this table you can find out. This is basically I've got it 3.89. So this is basically 3.89. Here is basically our inference is basically here. This value, tabulated value, whatever we have got it here, 8.4 is basically that calculated value. Calculated value of F is 8.4, and here is basically 83.89. So here we can say that since the computed value 8.14 is greater than the table value, which is 3.89, so we can say that we have basically, we can reject, basically we can say that reject the null hypothesis. So here we can say that here I'm basically here this computed F is 8.4 is basically greater than the tabulated value of 3.89. So we can reject the null hypothesis. That means here is basically we can say that this sigma 1 square is not is reject means, or we assume this one, we assume this is basically equal to sigma 2 square is equal to sigma 3 square is basically was null hypothesis was this, and rejecting means it is not. Are you getting my points? That is basically we can say that we are considering that there same is there is no difference. We consider there is no difference. But here it says that the null hypothesis reject means we are basically not same, different, that there is some effect. So it means the it is non-hypothesis there is a significant difference. We can say that there is a significant difference. So that means that the effect of the seed is basically having a significant difference. Okay, that is basically our this. But the same thing, with the same type of, this is basically from here, I can say that. So if we go for the two-way ANOVA, is it clear? Anyone, please? How I have done the calculation? And the same type of problem, what we can do it for simply for two-way ANOVA. So with this one, what we can do? Where we are taking about that the plot of land, we are taking about that plot effect of the plot of land. Okay. For this one, what we are basically talking about that, yes, it is basically hypothesis. We are basically considering that same thing, sigma 1 equal to sigma 2 equal to sigma 3, and alternative basically at least two of the population means is unequal. So then we can say that what is basically happening. So for this one, what we can find out that for this one, we have to basically add two different, I mean, we can find that here we can find out that column total, which is nothing but equal to, I have already added earlier 25. It was basically 60. It was basically came on 05. And he, previously it was basically what we calculated earlier. 30 plus, it is basically this is 25. This was 20. And this was basically 60. And the total was 60 plus 20 is equal to grand total is equal to nothing but is equal to on 05 grand total is equal to grand total is equal to 120 on 05. Similarly, what we can find out here, the from column also row, whatever we have to do this and from there, whatever we have to for this one, the calculation, whatever we have to find out that the correction factor here, correction factor we have to find out. And this correction factor will be equal to T square by RC, which is basically number of row into number of columns. Here, this will be nothing but is equal to column wise total, basically 25 plus 20 plus 60, its whole square, divided by RC equal to 3 into 5, which will be finally will be equal to 735 will be our calculation. So here, whatever we have to find out that column wise SSC. So whatever we have to find out that column wise SSC, which will be nothing but is equal to whatever we have got it 25 square by 5 plus 20 square by 5 plus 60 square by 5 minus of this correction factor of 735, whatever we have got it the previous one, this 735 we have got it, this 735 here. So from here, whatever we have to Find out this is basically nothing but of, we can find out this 125 plus 80 plus 720 minus 745, which is nothing but equal to 190. And second, whatever we have to find out that with basically row and SSR row wise, we can find out that it is basically 18 square by 3 plus 24 square by 3 plus 17 square by 3 plus 24 square by 3 plus 22 square by 3 minus of 735. So whatever basically you are getting these values, whatever you are getting, you see here 18 square by 3 this value, 18 square by 3 this value, 24 square this value, whatever from what you are getting. You are getting 5 plus 3 plus 10 is 18. Okay. So this will be 18 square. 6 plus 5, 11 plus 13 is basically 24. So you have got it. It's 24. Okay. Same thing, whatever you are getting with row wise, that is your whatever you basically, whatever we have taken it, that this is basically your basically total row total is basically 18, 24, it is basically 17, this is basically 24 again, it is basically 22. So you are getting that this value is basically corresponding to the 18, 24, 17, 24, 22. 18, 24, 17, 24, and 22. So we have got it by this and divided 3 minus this correction factor. We have got it. So this is basically this. And this is basically, with this, we can find out the value here is becoming 14.66. Then whatever we do, we have to basically SST, total SST, whatever we will get it basically from all this, all 15 characters. So whatever we are having, so first row, whatever we have got it 5, 6, 8 on 5, 5, 6, 8 on 5. So whatever we will do this 5 square plus 6 square plus 8 square plus 1 square plus 5 square. This is the first column plus second column is all you have to do it is 5, 3, 5 to 10. Here you are getting that 5, 3, 2, 10, 0, 5, 3, 2, 10, 0, 5 square plus 3 square plus 2 square plus 10 square plus 0 square. So in this way, we have to do the for third one, you have to do this minus of the 735 correction factor, 735. And there, whatever you have got in this value, you are getting basically 330, you have got this one. So it is basically for this one, SSE error will be equal to SST, here this SST minus of SSC for column plus SS of R. So there will be nothing but is equal to 330 minus of 190 plus 14.66, which is nothing but is equal to 125.34, 125.34. Then whatever we have to do, we have to do basically put it in this table. So here the values are basically between the column is becoming, we can say that here basically 190, it is basically becoming 14.66, and this is 125.34, and total is basically 330.0. Here C is basically 3 C minus 1 equal to 3 minus 1 is equal to 2. And here is basically rows, between rows is basically 5 minus 1 is equal to 4. And here residuals will be C minus 1 into R minus 1 is nothing but equal to 2 into 4 is equal to 8. And this total will be n minus 1, which will be nothing but is equal to 14. So from here, what do you get it? 190 by 2 is equal to 95. It will be 14.66 divided by 4 will be nothing but equal to 3.665. And here this will be 125.34, 125.34 divided by 8 will be nothing but equal to 15.67. And here this calculated value will be 95 by this will be 15.67, which is nothing but equal to 6.06. And here this will be 15.67 by 3.665, which is nothing but is equal to 4.28. Here, whatever the corresponding to 15 point is basically is 678. So whatever you can get it, basically this table will be for 2 by 8 table will be becoming 4.46. If you go to this table, if you go to this table, 2 by 8, 2 by 8 is becoming here 4.46. You are getting this value is equal to yes 4.46, and this value will be becoming same way. You are getting basically 15.67 is equal to 8 and 3.04. So this is basically 6.04 from this table. Now you are getting here. This is basically here 6.06 is basically largest. So what you can say that 6.6706 is greater than that calculated 4.46. So here we can reject null hypothesis. That is basically there is basically significant difference. There's significant difference in the variety of this weight. I mean seed, and since it is 4.28 is basically less than this, so there is no significance of land here. So where basically we talk about that the here land is has no significant effect, but seed having significant effect on this. That is basically here we are taking basically this two. So in this way we can easily calculate this. And these calculations are the small calculation we can do. But if it is the calculation in large, you can use just the mini-tab, though mostly mini-tab is to some extent earlier was basically free, but I think so that to some extent some module mini-tab is free, and you can find out this. You can do the calculation. So with this, I'm concluding here. Thank you for patience hearing.
Thank you, sir, for your wonderful presentation. Anybody have any questions? You may ask, sir. Thank you, sir, very much for your wonderful session. I am asking again the guest. Anybody have any questions? You may ask, sir. Sir, we would like to present one digital memento. Please wait for a moment.
সন্দীপ স্যার অনেকদিন পরে সামনাসামনি দেখা হচ্ছে নাকি, বাট ইটস ইজ এ ডিজিটাল প্ল্যাটফর্ম, বাট নাও ডিজিটাল ইজ দ্য নর্মাল প্ল্যাটফর্ম, তাই তো নাকি?
Sir,
থ্যাংক ইউ,
memento, sir, for you. I hope you like it.
থ্যাংক ইউ,
Thank you very much, sir.
ওকে, ক্যান আই লিভ?
Yes, sir. Yes.
Thank you for your giving me opportunity to discuss with you with my limited knowledge, experience. So I think so that at least you can motivate students so that they can at least add some value to their project. Thank you. Okay,
Thank
I'll
you, sir.
leave. Okay, bye.
Have a nice day. Okay. Everybody, the next session will start from 2:30 p.m. in the same link. Okay, you may now leave the link, but please everybody join before 2:30. At least try to join around 2:25. Okay. Thank you.